Oh, I'm sorry about that. We got sort of froze for a moment, but we'll pick up where we left off on number 2.
So what this is saying is take part B's answer and divide it by H. So you're going to just take part B and put everything over H. So 2hx plus H squared. And I'm just going to go each one of these over H over H. And those H's in the denominator better cancel out. Are they?
Remember, every term there has an
I think
H.
that the frozen video scared them. They're not speaking now.
Mm-hmm.
So here I'll get this one going. I'll cancel the H there. So all that we're left on the first term is just a 2 and an X.
What are we going to be left with on the second term? Something's going to cancel and we'll be left with a nice term. Okay, one H cancels above and below and we're left with just an H.
So 2X plus H. This is a nice 3-step approach for finding those difference quotients.
2X
plus H.
Mm-hmm.
Okay.
Number 3.
Mm-hmm. I think I'd better flip to another page.
Yeah, I think so.
Number 3. It says find the expression f of x plus h minus f of x all over h for h not 0. Would it make sense for h to be 0? Because you can never have a 0 in the bottom of a fraction, can you? It's called the difference quotient. Find and simplify the difference quotient in the following function. I would have liked it to have said to find the difference quotient using the 3-step process. I think that's how the business calculus book says. Mm-hmm. Use a 3-step process to find the difference quotient. But let me see. I'm first going to write down the function f of x equals negative 10x squared plus 5x and a minus
Plus 10.
Oh, a plus 10. Okay. Negative 10x squared plus 5x plus 10. Okay. And I'm going to color code. It says to find f of x plus h. Sometimes students ask, do we have to memorize?
No, the instructions will tell you what the difference quotient is each time. The instructions on the test will be just like the instructions here in the homework.
F of x plus h minus f of x all over h.
I see what you're getting at with these colors, okay.
I'm going to first of all find the f of x plus h in blue. Then I'll use red ink to do the minus f of x. And the minus f of x is just
crossing out
the stuff. What I'm going to do is, I'm on problem 3, I'm going to find the f of x plus h, and then I'm going to do this. Mark out, over h, rather than writing it up, taking up so much room here going through all the steps. But the f of x plus h, that's the involved part. Come up here and replace both of these x's with x plus h. And I know I forgot the square. There it is. Okay.
He's replacing each x in the original problem with x plus h.
Now, this one's a bit more involved.
But at the very least, I'll tell you right now, you won't have any exponents bigger than 2. Look back. If you were going to have to cube x plus h, you would have had to write it 3 times
And start
and
foiling.
start foiling all over again. Now take an x through, take another h through. So at the very least, yes, you'll have that x plus h squared, but you won't have an x plus h cubed popping up with these difference quotients.
I could just look back over here where I spoiled out x plus h.
I think it's a good idea
h.
for them to do it again.
Let's just practice doing it once more. This is where I'm calculating x plus h squared. This is my scratch work. It'd be x squared plus x times h. How am I going to write that? hx, good. First outer, inner. What's inner going to be? Another hx. If this is sounding familiar,
it should be exactly the same as it was a moment ago.
h times h is, okay. So we can add the 1hx and 1hx. So we'd have x squared plus 2hx plus h squared.
But look at this. There's something in front of that x plus h squared. What is it? A negative 10. You're going to have to distribute negative 10 over all of that stuff. Oh, you're writing it like that.
Oops. And I guess I could just go ahead and distribute this 5 right now. So it's a plus 5x and a plus 5h. And then we have the plus 10.
You see, I thought you were just going to stick on a negative 10 right there. So
I did.
That's okay.
I should have
You don't
maybe.
have to. Your form's better than what I was going to do. So.
Negative 10x squared.
Y'all tell me what the next term's going to be. It's distributing that negative 10. Okay. Negative 20hx and... No.
10. And we still have the plus 5x, plus 5h. Are there any like terms to combine here?
No,
I don't think so. There's the x squared. Oh, I've already combined the hx and hx. And there's really nothing else. This is why they didn't break it up into 3 parts. So you don't have to be typing all of this stuff in. But this is the hard part of the problem. Any questions on what I've done there? Because the rest is going to fall out really easily now. In red, what am I going to do?
You subtract off the original terms.
So there better be a 10x squared that I can negative 10x squared. Is there? Yeah. Sometimes students say, well, wait, what if there's not one?
Then you've done something wrong.
There better be a 5x I can mark off. Is there a positive 5x I can mark out? Yeah. And there better be a positive 10 I can mark out. Have I done that? So the red...
only terms left must contain the letter H.
Notice we marked out everything that didn't have an H. Now in green, over H, over H, over H, and call out what we're going to have as our final answer. What I'm about to write, once I cancel these H's, that's going to be the final answer. That's the difference quotient. So here, those H's cancel. Oh, this looks so messy. I have a negative 20x. Okay, good. You cancel the green H with one of the H's on top. So a minus 10H. And then what? Plus 5.
And there's your difference
is
quotient.
The difference quotient. Negative 20x.
Negative 20x minus 10h plus 5.
You want to move this over here?
Move
oh, yeah.
Any questions there?
That's called finding the difference quotient. Something very important for Calculus 1. Repeat the question.
My online students are taking their midterm, and I have to keep looking for if there's a problem. The testing center will call. So, and Monday was a miss with that outage. So, it's recording.
Yes, you sure got to be able to combine like terms to do this. Now, so that we've done the name of the assignment. Operations, that was problem 1. Oops. And then the difference quotient, that's problems 2 and 3. And now we're going to start the final topic in this assignment, something called composition of functions.
Now this is an operation, but it's not like addition, subtraction, multiplication, division. Those operations you can do just with numbers. That's how they originated. Composition of functions, it's an operation that's unique to functions. You can't talk about 3 composed with 10.
I'm going to write, it's going to look like I'm writing fog. F, and then it's a little open circle, G of X. I'm defining what I mean by this little open circle. It means this. It means F of this little blue open circle is just used instead of really big parentheses. G of X. So F composed with G of X means F of G of X. It makes more sense when you see it with numbers. And so, or with functions.
So but that's saying loosely, it's saying go to your function f of x, and everywhere you see a variable, plug in the other function g of x.
You're plugging
G of X. Go to the outer function and plug in the inner function.
Mm-hmm. In terms of just numbers, let's do number 4.
Okay.
We're told f of x is negative
3x minus 1. And h of x.
Oh, of course you're using an h instead of a g. Okay.
Functions can be named anything. F and g are the most common, but you can use any letter you want to.
So negative x plus 2, and it says to find
h composed with f.
Is that half?
Half 6.
Is HOF a word? It's got to be. I just said it.
That ain't a word.
Wait, half. What was it? 6. Oh, this is. I did.
You see, there's not an x there. We want to find a composition at a number. A composition at a number gives you a final answer. That's a number.
To find h composed with f of 6, or another way it might be read if you don't want to say composed with, h, just say of f of 6. What that means is start with this number 6 and plug it into the function beside it. Plug 6 into the function f. If I come to the function f and plug a 6 in there, what am I going to have? Negative 3 times 6 minus 1. I'm plugging a 6 right here. Negative 3 times 6 is negative 18. Minus 1 is going to be what? Negative 19. Take that answer, plug it into H.
So you still have that H on the outside there, H of negative 19.
So in words, what am I doing? I start with the number 6, and I start working to the left. Take the 6, plug it into F. That's what I did right here. I plugged 6 into F and got a negative 19. Now take that negative 19, plug it into H. So if I go to this H up here, now this is going to be a little tricky. Watch out. It's negative x plus 2. Why am I saying it's a little tricky? We have the blue negative, and we're about to have a, that black negative, negative, negative. You'll see how I made that into a positive 19?
You know, I might be colorblind because your blue and blacks all look the same to me.
It does look very similar.
Oh, okay. I know that's not how colorblindness works, but still.
Is that 21?
Mm-hmm.
In words, what did we do? You start with number 6, plug it into the function beside it. Take that answer, plug it into the function beside it. Let's go ahead and punch that one in.
Realize that composition of functions is really just repeated function notation. Whatever that number. Oh, I'll be quiet.
Oh no, I'm going to say, instead of doing that next problem, I'm going to stick with that same problem. F of x is negative 3x
minus 1.
I'm going to make up an example. And h of x is negative x plus 2. In the problem 4, it said to find half FOH of 6. What if I reversed it? Instead of H composed with F, suppose I'd written this. Is it the same thing?
Are we going to get the same answer?
And are we going to do the same thing? I mean,
where are we going to put that 6? Into H. Okay.
And then we take that answer and plug it into F. Y'all see the difference? Over here, we plug the 6 into F, plug that answer into H. Now, we take the 6, plug it into H. So we have a negative 6 plus 2. When I plug the 6 into H, what am I getting? Negative 6 plus 2, negative 4. Mm-hmm. Now plug that answer into F. So I took the 6, plugged it into H, got a negative 4, plugged the negative 4 into F. So go to your function F now, and in place of this black X, I'm going to put a blue negative 4. So what are we getting as our answer here? The negative 3 times negative 4, that's a 12. Minus 1, what am I getting? 11. Oops.
Operations are classified as commutative or not commutative. Addition is commutative. A plus B always equals B plus A. What about subtraction? Does A minus B always equal B minus A? No, usually it doesn't. So subtraction is not commutative.
Commutative means the order doesn't matter.
Okay. A times B, does that always equal B times A? Is multiplication commutative? Yes. What about division? Does A divided by B always equal B divided by A?
The only way that would be if A and B were equal.
Mm-hmm.
10 divided by 5 doesn't equal 2 divided by... No. 10 divided by 5 doesn't equal 5 divided by 10.
So the question is, what about this new operation, that little O? Where would we put that operation? Is it going to go with commutative or not commutative?
Does F composed with H? We got an 11. Does that equal H composed with F? No.
So, composition of functions is not commutative. If they ask you to find F composed with G and you mess up and find G composed with F,
you're getting the wrong.
You're going to get the wrong answer. Sometimes they're the same, but not always, and not usual. As a matter of fact, there's a special set of functions that it doesn't matter how you find their compositions. Everything cancels out except for X, and we'll be seeing that eventually. But
let's look at number 5.
Okay. Goodness, it's taking me.
Oh gosh. Okay, I guess I'm going to write down the tables. F of X. The way we defined a function, we said a function is a rule which assigns to each x value exactly one y value. That's what this table's doing. The x value 3 is being assigned the y value 6. The x value 5 is being assigned the y value 3, and so forth. That's function f. Oh, I'm pointing here and they can't see what I'm pointing at.
I should have been pointing like this.
X, G of X.
11, 7, 2, and 20 are the X's.
11, 7, 2, and 20.
And the y values are 8, 5, 3, 21.
So on this one, instead, here it is, fog 2. Most of the time it's fog and golf that they write. And of course, for the very first one, just to confuse you, they had to use an H. So it was fo and hoff. How would you pronounce F-O-H?
I don't know.
Okay, here we don't have formulas to plug in. You got to look at the tables.
Which table will you use first?
Start the 2 and look at table G.
Okay.
So on table G,
the x value of 2 is assigned to what number?
3. Now,
we still have something in front. What is that? An F? So now you're going to use the F table. I need to be quiet. You have the microphone. Okay, go ahead.
Well, you want to talk, so just go on and talk. F of 3. What's the y value being assigned 3? Well, let me ask, what's the answer going to be? Is it going to be 6 or 5? The number in the parentheses is always x. Okay, so f of 3 is 6. There's just not a lot of scribble work to show here. Writing to show how I'm doing. So let me just say it again. I look at the table G to find G of 2. Here's the table G. G of 2 is 3. Then look at the table F to find F of 3. F of 3 is 6.
Okay,
Type that in.
Oh, I like this one better than number 5.
Number 6, they give you 2 tables, F and G, but look at what they're asking you to find. Are there any G's in what you're trying to find? No.
So don't waste your ink writing or lead writing down the the G table. All that matters is the F table.
Let's see. 4, 7, 11.
Is assigned to 8, 4, 6.
8, 4, 6.
Yes.
FOF, does that?
FOF 7.
FOF 7. Okay. Well, just sort of, let me lift this up. There's not a lot of work here. By work, I mean it's up here. Okay? Not scribble, scribble. Start with 7. Look at the F table. What's F of 7?
The F table assigns 7 to 4. Okay. You still have another F there in front.
So look at the F table again. It's assigning 4 to what? 8. Again, how can I write this out? There's not a lot of scribble, scribble. I'll say it again so you can listen to the video. F of 7 is 4. F of 4 is 8. Any questions there how I got that? And hopefully it's clear why we didn't write the G table down. It didn't say to find fog or anything, or golf. It just said F composed with F. Actually, I say fog and golf only because, well, because I want to, but also I think you remember that more than you remember the name composition of functions. If you're in Calculus 1 and y'all are studying the chain rule and the teacher asks, did y'all do composition of functions in algebra? 99% of the students are like, I don't remember. But if they say fog and golf, oh wait, I remember fog and golf. I might not remember how to do it, but I remember the idiot sitting up there talking about fog and golf. It's not really fog and golf.
It's as bad as psych, I think, Tony. Remember, it's at the point for Burton Guster. He used to be so sensible, and Sean Spencer was the crazy one. But now, Burton Guster's there just going along with all that stuff that they do, and I'm going along with it. That fog and golf, when Tony used to talk about that, I could just feel my blood pressure shooting up.
I tell my
Don't
students,
call that.
if your calculus teacher asks you, if you say fog and golf and your calculus teacher says, who did you have for algebra? My name is Timothy Precella.
He is
Not really, but it annoyed the heck out of us.
I don't know why now. Yeah. I don't know why it used to bother me so much.
Now we're going to continue on. We still have 7, 8, 9, 10, and 11. 7 more of this fog and golf stuff. So here's problem 7.
Notice the instructions. A composition, add a number. That's what we've been finding. We've been finding a composition, add a number, and the final answer was a number. Now we're finding a composition at x. And so we expect our final answer to be a function of x.
Let me write down. F of x is 8x minus 8, and g of x is 9 minus 2x. I was reading that untreated eye problems, that's an indicator or can lead to Alzheimer's. So y'all are young, it don't matter, but if you have bad vision, you need to get some glasses or something. Untreated eye problem, and a new warning sign that leads to Alzheimer's, high cholesterol. So if you have high cholesterol, try to get on some cholesterol medicine.
I don't remember, did they want F composed with G or G composed with F? Oh, they want both of them. They want F composed with G of X and G composed with F of X. Do you think we're going to get the same thing in both answers? Probably not.
Okay, watch how I'm doing this. There's not a number that you plug in. What this is saying to do is take the function G and plug it in to f. You're plugging the function g into f. Let me come back up here, and I'm going to put those same little arrows. I'm going to plug the function g into f. So in place of this blue x, I'm going to put the pink 9 minus 2x. Let me set this up. For 8x minus 8, in place of the x, I'm going to write 9 minus 2x. Now, the arrow's demonstrating what I'm doing. This means plug g of x into f of x. That's all this notation is. It's just notation instead of writing out the words. Plug g of x into f of x. Now, let's see. What would y'all do to simplify this? I guess we could distribute this 8. Tim, do you want to try to get them to say answers? We'd have 72 minus... Oh, you're not speaking? Okay. 16x. And we still have the minus 8. So what are we going to have here? Just a 72
minus 8? Why
No.
divided that twice?
I'm going to... Oh my gosh. 72 minus 8, yeah.
That's going to give us
64. Then a minus 16x. There's our answer for f composed with g of x, or fog x. 64 minus 16x. You take the function g, plug it in to the function f.
Now go backwards.
Now it's
G
asking us to...
composed with f.
Could y'all say in words what this is saying to do? That's all this is. This is shorthand notation. When you see this here, you got to know. It means plug
F
F
of x into
G. You know what?
You should have written it twice.
I'm going to rewrite f of x equals and g of x equals. I messed up. I should have rewritten that just so I can make my little arrows.
So it's going to take
Could y'all draw? Okay, so I'm plugging
f of x
The colors might not mean anything to y'all, but it means something to me. Okay? This says plug. Okay. So I just rewrote the F and G just so I can draw the arrows and it not be too messy. It means plug F into G. So what arrows would I need here? I'm going to plug F into G. So in place of this pink X, I have a 9 and a minus 2. But what am I going to put in place of that pink X? 8x minus 8.
Do not subtract here.
Don't.
Multiplication, the order of operation says you multiply before you subtract. So you're multiplying a negative 2 over that 8x minus 6.
So we have 9. Then instead of minus 16x and
what are we going to have last there? A plus 16. What can we combine now?
9 plus 6.
Which gives me 25 minus the 16x.
if you want to write negative 16x plus 25, that is fine.
My lab would take it either way. Any questions there? And
Yeah, I made a
notice,
mess out of
as we said, in most cases, F composed with G will not equal G composed with F. I better type these answers in.
So 64 minus 16x is the first one.
64 minus 16x. And then the second one was
25 minus 16x. Okay.
number 8.
Same thing. Let me see if I can do this neater. F of x is 9x plus 8. And g of x is square root of x. We're going to find fog x first. And I'm going ahead and writing it down twice so I don't forget and mess up the way I did a while ago. It wants us to find both of these, fog x and golf x. Okay, let's see. We're going to start what this first notation means. What it's saying is plug blank into blank. What's the blanks? Plug.
G of x into f.
Did y'all hear that? Perfect. Plug g of x into f. So that means, in place of that blue x, I'm going to put that pink square root of x. It looks like I just wrote down, if you just look at the finished product, what did I do? I just wrote down the problem and wrote down the answer and drew a few arrows. Well, yeah.
That's your answer.
But there's your answer. 9 square root of x plus 8. So we're plugging square root of x into the function f. I guess I didn't need to leave so much space there.
That's
but,
okay.
yeah. Okay. What about the second one here? I'm going to plug what into what? Very good. Plug f of x into g. And so while I'm just sort of thinking as I draw these circles. Okay, I'm plugging f of x into g. So in place of that pink x, I still have the pink square root, but what am I going to have in place of the pink x?
9x plus 8.
Mm-hmm. There's another one where there's not a lot of scribble, other than maybe drawing some arrows or something. Like on number 7, there was a little bit of distributing to simplify it. Here, there wasn't even that. So here we have a 9 square root of x, and only the x is under the square root of x, under the square root.
Get out of that radical, plus 8. And what am I going to type first for g composed with f? The square root. That radical is going to go first, and then everything's underneath it.
The 9x plus 8.
The 9x plus 8 is underneath it. Any questions there?
Gosh, this looks terrible. My page here. Maybe it'd look better if I didn't have that big mark. Well, anyway. Are we ready to try this one? Let's see. Number 9. I'm going to stick with the same colors just because they're so different.
Yeah, you can distinguish the two.
That way they
I
don't...
wondered about green and pink.
Oh, okay.
But no, you said it.
Square root of 2x is f of x, and g of x is 1 over x. And we're told to x. I like what I did a while ago. I'm going to leave a little room. F of x, square root of 2x, g of x. Again, the reason I'm recopying these is just because with my arrows, it looks so messy. Or it could look so messy.
G composed with this.
Okay, so, oh wait, this green is the better one. Okay, so fog x, we're going to plug G into F. So in place of this blue x, I'm going to put the pink 1 over x. That's going to make it a little messy. Okay? So I still have the blue square root, but it's going to be bigger. Then we have a 2.
That's 2 times x. So now we're going to have 2 times 1 over x.
And y'all know how to multiply fractions. There's a little bit of work here. If we think of this as 2 over 1 times 1 over x, what are we going to get there? How to multiply?
2 over
2 over x. 2 times 1 is 2. 1 times x is x. You just multiply straight across. There's nothing to cancel there. Okay, so you can say, oh, I'm canceling the 1s and I have a 2 over x.
Okay.
Y'all follow what I did there?
Yeah, I think they followed it. Do the next one.
Oh, okay. Okay, so let me think. What does this mean? G of f of x. That means plug f into g. So I'm going to put all of this, the square root of 2x, in place of the pink x. So I'm replacing this pink x with the square root of 2x. So we still have the pink 1 over. I'm writing that down. Instead of the pink x, I write square root 2x. And you know what, Tim? You fell down on your duty.
I did.
You didn't say box your answer.
I was just going to see if you remembered.
Oh, okay, well, I did eventually. Okay. And this all of a sudden looks like a 7 here to me, but it's a 1. Oh, okay. So you want to type those in?
Okay.
It's
For f composed with a g, what am I going to type first? I want to type in this answer here. What will I click first? The square root. That's right, the square root. And then I'm going to put a fraction hot button just to make sure that I type what I want to type. So the 2 goes on top, the x goes on bottom. Now this one, we're trying to type 1 over the square root of 2x. Am I going to click the square root button first? No, what am I going to click first?
I've already said
fraction. Okay. So there. Then I have the 1. Click down there, the square root of 2x.
I think the next problem, they start asking you a question. Let me ask you about this. I'll ask you on this one. It's going to ask, if you had this question, how would you answer this yes-no question? Did these two answers, are they equal?
No.
I heard no, and that's right. I think on the next 2 problems, they're going to have that extra question there for you.
Normally you expect the answer to be what? If they ask that for number 8 or number 7, what do you expect the answer to be? And I think you expect it to be no. They're not equal.
Because we said they're not, it's not commutative. The order does matter. Commutative means order does not matter.
Oh, that not commutative means it doesn't matter. commutative means it does matter.
Oh, yeah. That not
Just drew a little brace tone in.
Right.
Move it like this. Order does. Oh, it does
Does
matter.
it matter?
Oh, you're
I
right.
know.
Yeah, you're
Oh.
right. I'm. Oh.
Okay.
Well, I'm
A plus B is
I'll
the same
keep my
thing as
mouth
B
shut.
plus A. A times B is the same thing as B times A.
Look at number 10.
Ooh. Oh, number 10 doesn't look bad. So it's the same instructions as the previous problem, except we do have an extra question. Show them the extra question.
Right there.
Okay.
Determine whether f composed with g of x is equal to g composed with f of x. As we've said, in most cases, the compositions will not be equal. The mere fact that they're asking, are they equal, makes me think these may be some of those exceptions. Maybe they're trying to draw your attention to the fact that for this problem, they're going to turn out to be equal. Let's see. Are you ready?
Uh-huh. Oh, wait, no, I'm not. I got it.
You got to
No.
write it twice. Hold
Okay.
on.
And I'm assuming it's still asking for fog first.
Yes.
Okay, so we're finding. Okay, so on this one. Oh, piece of papers. Okay, to find. Oh,
Oh, my.
F composed with the G of X, or fog X. That means plug G into F. Oh, so all of this is going to go in place of the blue X. So it's going to look a little messy. I'll have the blue 8. And then in place of this X, I'm putting all of this stuff here. Now keep in mind, that means this 8X means 8 times. So we have a 1 over 8 times X plus 6. And then it's very tempting to forget the minus 6. But don't. There. Oh, gosh.
It's not that bad because you multiply from left to right.
What's about to happen with this 8 times 1 over 8? If you think of it as 8 over 1 times 1 over 8, what's going to happen?
Something's going to cancel.
Yeah.
The 8's cancel
So we just have a 1.
to distribute over the x plus 6, which is just...
So we have X plus 6. And we still have that minus 6 there.
which reduces to...
The 6's subtract out. What's left there? Just X. So F composed with G of X here. Notice how this stuff canceled out. If you get two functions in which everything cancels out except for X, we're going to give them the name inverse functions. But we're not giving them that name today. We'll give that name another day.
1 week's time.
In 1 week's time. Now to find G composed with F of X. So what does that mean? This means plug F into G. So let's see. Plug F into G. So in place of the pink X, I'm going to put the blue 8X minus 6. So I'll have the pink 1/8, don't forget it, and then the pink parentheses, plus 6, plus 6. In place of this pink X, I'm putting the blue 8X minus 6. And this is all going to simplify really nicely. What's happening here? inside the parentheses, what's happening to the 6's? -6 plus 6, those are 0, they're gone. So the 6's have canceled out. Now all that's left in the parentheses is the 8x, and down here we have a 1 over 8. What's about to cancel? The 8, leaving me just x. Now when we ask the question, does fog x equal golf x? Yes or no? Yes. A week from today, we'll give these type of functions. That's how we'll begin the class, by reminding y'all of these two problems, 10 and 11. If everything cancels out and you're left with just x, then those functions are called inverses of each other. Now, oh wait, you better type in answers. It's x, yes. And one more. Number 12 and 13, those are some little cut point inequalities, just so you don't forget that cut point method. Oh, I've got to see the, no problem. F of x is, oh my gosh, well,
This cube root of 6x plus 7.
and
G of x is 1/6 x cubed minus 7/6.
So we're going to try to find log x. We're going to find golf x. Did I miscopy it?
No, I was just
Okay.
making sure.
Okay, f of x is the cube root g of x is 1/6 x to the third. I'm just up here mumbling to myself. There, so I've just set it up now. So to do the first one, f of g of x. That means plug g of x into f. So, oh gosh, it's going to look sort of messy, isn't it? I'm going to have to plug all of that in place of that blue x. So in place of the blue x, I put the pink 1/6 x to the third minus 7/6. Ah. If I think of this as 6/1, I'm going to start by distributing that 6. And don't panic, because it's going to work out really nicely. What's going to cancel when I distribute this 6? The 6's?
This,
Yeah, the 6 will cancel with that 6 and that 6. So what's left there is just the pink x to the third and the pink minus 7. But we still have this pink plus,
No, the
the blue plus 7 there. Oh gosh. Are y'all following what I did here? Any questions on this? It looks a mess, I know.
What's about to subtract out or disappear under that radical? The 7's. All we have left now is the cube root of x cubed. What's the cube root of x cubed? Just x.
The cube and cube root cancel out. The -7 and +7 canceled out also, leaving just
X.
X is the answer. Hey, based on the previous problem, if you were just going to guess, what are you going to guess the other one is? X.
It's very difficult to have one direction reduced to x and the other one not reduced to x. It can happen.
But
That's why you need to check them both.
But if you have to guess, you have about an 85% chance
of being right if you say x for the second one also.
You want to be 100% right rather than just 85. So we'll do both of them. Plug F into G. So plug all of this, oh gosh, this into G. So in place of the pink X, I'm going to have this big cube root. So I'll have the pink 1/6. Then, I guess I'll do it like this. Is that what you would do, Jim?
Mm-hmm.
Cube root 6x plus 7. Okay, now, how is all of this stuff gonna simplify? What cancels first?
The
Cube and the cube root. Those cancel, so they're gone. And I think I'll rewrite it. So if the cube and the cube root cancel, then we're just left with 6x plus 7 in the parentheses here. And now, distribute. Oh, you got to distribute a 1/6, but you can handle it. The 1/6 times 6, what's going to happen there? So 6's cancel, and we're just left with 1x or just a x. Y'all see why I'm just writing x here? The 6 and the 1/6 cancel. And now 1/6 times 7/1. Nothing cancels there. You just have a 7/6. 1 times 7, 6 times 1.
And what else do you have stuck on there? Okay. And what's about to happen? Leaving us with just... Okay.
Yeah. It's pretty...
1 week from today, we're going to be discussing, the whole class will be over inverse functions. Those are functions whose compositions reduce to x in both directions. And so I'll be reminding you of these problems 1 week from today, and I'll be telling you. They were trying to prepare you for inverse functions.
Well, yes or no? Does fog equal golf on this particular problem?
Yes,
Yes.
it does.
So XX, yes. That's the answer for 10 and 11. X. Any questions on this? Oh gosh. Hey, is it still recording?
Yes.
Okay.
Right there.
Oh,
I
okay.
hid the little recording bar, but
Oh,
it's still
okay.
recording.
12 and 13 are cut point problems. Are there any questions on this? Don't wait too long to do it, to do your homework on this, because you'll forget and you'll be looking back, what the heck is he doing? You know, drawing those arrows and stuff. But I just don't know a better way or to show what, or to try to show what I'm doing there. F of g of x means plug g of x into f of x. Golf x means plug f into g. It's just a shorthand notation. Instead of writing out, plug g of x into f. That's what this notation means. Plug f of x into g. There's the shorthand notation. So, any questions there? Are we ready to stop recording? Do you have any questions you want recorded? Listening?